very much, Brittany. Thanks for the introduction. As Brittany said, this is a pretty unique webinar for us, and I'm pretty excited about it. We're looking at implementing a hybrid cloud solution. Much of this webinar is really going to be a demonstration of a solution that we've got in place. And on the webinar today, we've got myself, Tracy Wallace. We also have our IT director. I somehow roped into this, and I'm pretty sure the next time I ask him for anything, he's going to say no, but that would be Jamie. And I've known him for 18 months, and I'm not going to try to pronounce his last name because I'll get it wrong. And we also have our intrepid network engineer, Carl Zellers. Guy is absolutely fantastic and really did a lot. He didn't know until yesterday that he was going to actively participate, but I think given the work that he did really getting this set up, I thought it'd be cool to have him describe what he's doing just a little bit. So just a quick brief thing about me. I'm Tracy Wallace. I've been teaching and working in IT. Well, I've been teaching for over 25 years. I've been working in IT for over 30 years. And I really come in from the Azure side as far as all of this goes. I've been working with Azure since 2011 and really playing around with it. And Jamie, in addition to being our IT director, is also really our AWS expert. And Carl is really here because Carl does everything, but he really did a lot of setup on our on-prem. And so what I'd like to do just real quick is let both Jamie and Carl say a quick hello. Jamie, if you want to go ahead and take the mic and introduce yourself.
Hey, my name is Jamie Kahgee. I am the IT director here for INE. So one of my tasks is to help oversee our cloud infrastructure setup. So I got the invitation to help Tracy put on a presentation here with the implementing the hybrid cloud solution, and looking to have a great conversation today about how we brought these two clouds together and connected them up with our on-prem solution.
Absolutely, awesome. And Carl, if you want to take the mic real quick and introduce yourself.
Hey everybody, Carl Zellers. I am a network support engineer at INE. Always enjoy joining webinars when I can, and definitely like being a part of them from a technical aspect. So it's always fun to get on here and do some of the back end work and also join and maybe contribute some. So mostly on the networking side of things in general, but not necessarily strictly limited to networking. Do a lot of VMware and virtualization support and all that kind of stuff. So like Tracy said, kind of a little bit of everything, but primarily in the networking security space as it relates to kind of, I guess, my expertise or kind of mainline duties. So
Awesome. All right, cool. Yeah, pretty much if you ask Carl to do it, you can pretty much assume it's going to get done. So, but this isn't about us. This is really about looking at excuse me, looking at cloud solution. And one of the reasons why we're really looking at hybrid cloud a lot within INE is because if you look at the numbers, not only the numbers of people that are, the numbers of organizations that are moving into cloud or have moved partially into cloud, but two other things I think are really interesting. I saw, and I forgot to grab the link, but I've seen different stories where they put the number at around 80% of the Fortune 500 companies that are in the cloud are in multiple clouds, right? So a real enterprise solution is unlikely to involve one cloud. And also, if you're in the cloud, it's likely that you are not solely in the cloud, but you're also going to have on-premises, and you're going to have that really probably forever, or at least as long as your organization exists. Now, we set up this demonstration for this cloud with those three components. And what we're going to talk about are at just the highest level, some hybrid cloud basics. And if you're a networking person, this is going to be super basic. And if you're a networking person who is kind of wondered about the cloud, I think you'll find, and as we talk through this, and I want to talk to Jamie and also to Carl and kind of get where they felt what they felt about moving into a cloud environment and connecting up. But I think you'll find it's really not that different. And then what we're going to do is I'm going to go through our demonstration environment, And I'm going to go through that with Jamie and also with Carl and look at what we set up for the demonstration. And then I'm going to demonstrate. Really, the demonstration is going to be mostly just, okay, hey, here's what I just told you we have, and here's how it works. And it works. At least it did 10 minutes before this webinar. So, you know, if something goes completely awry, as often happens in live demos, you're just going to have to take my word that, in fact, it does work. No, we should be good. All right, now for a fun part, I want to map out some hybrid cloud basics here. And what I'm going to do is I'm actually going to stop sharing here and start sharing over on my other machine. All right, there we go. I think that actually worked. Outstanding. All right, you know, when we think about the cloud, when we think about hybrid cloud, you know, when I start out, what I want to think about is saying, okay, let's not even talk about cloud. Let's say that I've got, oh, I don't want to do this whiteboard. I want my whiteboard. All right. Strike one, shared the wrong thing. I have a much better whiteboard. Let's do this again. Microsoft Whiteboard. There we go. Mostly I like this because the Microsoft Whiteboard actually makes my terrible drawings into shapes. So that's beneficial. All right, let's say that I've got an on-prem environment, right? Or just usually makes them into shapes. There we go. All right, let's say that I've got 3 data centers, right? I've got DC1, I've got DC2. Sometimes it's not always what I want. That's ODC2. Wow, that's fantastic. All right, and we're going to say D3 because my drawing ability here is definitely substandard. Get rid of that guy. That's great. All right, as I bring this to a screeching halt, there we go. So I get DC1, DC2, and DC3, right? And you're going to set up some sort of connectivity. Now, that connectivity that's between them, this could be, frankly, 3 data centers that are set up as a local area network, could be a campus area network, could be a wide area network, right? But you've got some sort of connectivity, and that could be anything from private switch network, you know, using MPLS and a bunch of other protocols that I could throw out there, and then Carl's going to have to come back and say, you kind of use those wrong, right? But you can connect these up, right? You can even connect them up over VPN. That's fine, great. We can do that. Now, here's the thing. We're not talking about our on-prem, our internal enterprise, right? So what we're talking about is we're talking about really over here and over here. Well, this might actually be Azure. And this might actually be AWS, right? Well, really, the diagram itself, though, doesn't change. You know, I've got Azure, I've got workloads in Azure, I might have services over here in Azure. I'm running platform as a service, maybe I'm running a database, maybe I'm running a web app. You know, I might have some VMs over here. Might have some EC2s and some services over here. So you don't have to watch me write a box, right? Maybe I've got some virtual machines running various workloads on-prem, okay? But the cool thing is, as long as I'm connected, it's really transparent. And we're gonna take a look at that. We're gonna take a look at saying, okay, you know, how do all of these things talk together? How can we make them talk together? And not only can we connect these up over VPN, but also there are private circuit options that you could set up between on-prem and Azure or on-prem and AWS. In Azure, you could set up ExpressRoute. In AWS and Jamie, I can never think of the name of it. What's the private circuit in AWS?
Direct Connect.
Thank you. I don't know why that's so hard for me to remember, but it is. All right. But in any case, really, you know, I don't want you to feel like you wasted your time coming to this webinar, because I think it's pretty cool what we show. But for me, and I'm coming into this as someone who's not a network expert, right? But as far as setting up the connectivity, I don't really see where it's fundamentally different than if you're setting up connectivity, particularly in a wide area network. Jamie, would you say that's a you know, having seen it from your side and more on the networking, is that a reasonable thing for me to say, or is that just completely off the wall?
No, I would absolutely agree with you on that. So,
okay. I think, you know, what you'll find is, you know, on the one hand, and I promise you this is the case because I can do it. On the one hand, in the cloud, you're not going to have as many configuration options. You're not going to be setting up the hardware. You're not going to be setting up the switches and the routers at a physical layer. So you have a much less complex setup. Now, it also means that you have a somewhat more limited setup than you would if you're in that on-premises environment. And, you know, but beyond that, it's not really something that I would say is just this absolutely dreadfully different environment. All right. And that's really it. Now, I know that's not a whole lot. It's very high level, very basic, but to me, that's kind of the point, and that's what's really cool. And with that, I can get that out of the way, and we can get back and take a look at what we actually did. So I'm going to go back and share. Find the right one. There we go. Okay. So hybrid cloud basics, the moral of that story is it's actually not substantially different than what you would do if you were setting up your own, again, particularly wide area network. Now, one thing that I'm going to throw out there to you is please don't hesitate to throw some questions out. You've got at your disposal expertise across Azure, AWS, and on-premises, and you know, we'd love to help you out. And as Brittany said, any questions that you have, if we don't have the capability or ability right at the moment to answer them, we'll certainly copy them down and get them to you. I've been doing this long enough that I know I don't know everything, and I'm not going to be ashamed if you hit me with a question. In fact, I hope you do. Hit me with a question I don't have the answer to right away, but I will get the answer back to you. So with that being said, let's take a look at what we have. Right, this is the environment in kind of a big picture sense that we set up for the demonstration. Right, we have an on-premises network with effectively 2 data centers. And the on-premises network is, one of those data centers is actually connected via VPN to Azure. And the other data center is connected via VPN to AWS. And we also have a VPN tunnel between Azure and AWS. Now, we have a workload, right? Because this is all about hybrid solutions. Now, the workload we have is effectively just a REST API test. Okay? If you're familiar with the idea of REST API, it's just service calls that are being made over HTTP or HTTPS. In this case, HTTP, because quite frankly, I didn't want to deal with any certificates because it wasn't really particularly germane to the content. Now, the load that we're running is, as I said, it's primarily this REST API, just this service that's looking for requests and then sending data back. And I've actually got this set up and running, the same service is running in 3 locations. I've got a machine running in the on-prem environment that is running this workload. I have a machine running in AWS that's running this workload, and I have a machine running in Azure that is running the workload. And I've got a simple web page where I can put in the IP addresses of the services I want to hit, and it's going to test and make sure that it can get to those services. Now, of course, you can, you know, just run a ping, right? So for you network folks that maybe, you know, say, hey, look, if I can ping, I can get connected. We can do that. And in fact, earlier this year, I ran kind of a smaller hybrid example, just going on-prem to Azure. And really, that's pretty much what we did. But we thought it'd be more interesting to actually load a little something up that's a little more visual. Although I'm also going to go ahead and show you connectivity via ping, because I think that's by law necessary in any kind of environmental or any kind of networking environment, excuse me. All right, so anyway, so we've got these three servers that are running this REST API workload. And we also, though, have a service. And I thought it was actually pretty important to put this in, right? Because one of the things as you start to look at moving into cloud and whether it's hybrid cloud or cloud first, it's not just about virtual machines, right? All of your cloud providers, and I know I can speak certainly for AWS and Azure and Google Cloud Platform and even the Oracle Cloud Platform, right? There's these services that are platform services, whether it's database or web hosting, where you're not running it on a virtual machine. And I thought it'd be kind of cool to tie that in. So I've got an instance of an Azure SQL database running, and these services all tried to connect. Some are going to connect successfully, some not. And I'll show you why that is. It's just a little bit of a one of those tweaks that you have to deal with when you're going through, setting up the cloud. So it's a couple of things that are a little bit more challenging, but all in all, pretty straightforward. We've got this, again, REST API workload. It's running on 3 different servers, and I can connect to one of the servers and run a test to see exactly what's going on with that connectivity. All right, now that is the overall. And what I want to do is dive in a little bit deeper. We're not going to go completely massively down to every bit of configuration, but on the on-prem side, this is effectively what it looks like. I'm going to take you through it a little bit, and then if I missed anything or if there's a detail or two that our networking genius would like to cover, because quite frankly, he set up much of this. Jamie set up some, and Carl set up some. But anyways, here's what we have for on-prem. We have 2 data centers. Now, these data centers are connected by a private network. And both of these have external firewall endpoints. They're different. In fact, I believe they're different vendors. And each one of these is connected over a different ISP to a different cloud provider, right? So we have that R1 side, and R1 is connected through an ISP to Azure. And then our R2 side is connected through a different ISP to AWS. Now, one thing to note, and I have to give you this, or our networking people would be very angry with me. This is just how we set it up. And one of the things I wanted is I wanted something that was, a little more than just simple, okay, I'm on-prem, I'm in one cloud provider, we set up a VPN tunnel, we're good to go. I wanted to make it a little bit more complex, right? And something that is maybe a little bit more like what you would have in an actual enterprise environment. And again, it's not by any means the most complex enterprise environment, but that's what we have. Now, in the data center one, we have a couple of virtual machines. We have our web server, which is running at 192.168.1.100, and it's running Ubuntu with Docker, and it's got actually, it's an ASP.NET Core MVC application running in a container on top of that, right? And then we are connecting via VPN over IPsec, and we're using BGP for route advertisement into Azure from Data Center 1. Again, Data Center 1 and Data Center 2 are connected, and then Data Center 2 is simply connected up to AWS with a similar configuration to what we have on Data Center 1. And we have it set up, and I know Carl put in some routing rules so that we've got complete connectivity. So Carl, is there anything you want to add to what we're doing in the on-prem environment?
Yeah, good intro. So like Tracy said, as far as the design, the idea wasn't necessarily to project any kind of design that adheres to certain best practices or anything like that. It's more of a conglomeration of connectivity that gives us or myself some talking points for consideration when designing the on-prem side to interact with the public cloud. So what we've effectively got Within our data center virtualization, we're just simply ascribing to the 3-tier model, web, app, and database as our subnets that live in our data center. That allows us the flexibility and control within the data center itself for services, as well as anything outbound up to the cloud. What we've done from a high level view, though, if we're talking on-prem, the enterprise, what we're generally looking at with cloud connectivity is, I would say, the small to medium-sized business up to the large enterprise, you're probably going to have some form of redundant internet service provider connectivity, whether your goal is to have failover load balancing, or just media diversity as it pertains to the connections themselves, whether you mix coax and fiber, cell, whatever it may be.
Carl, can I interrupt for 1 second?
Oh, sure.
On that point, one thing that's pretty cool is, in full props to AWS, is that when you set up the AWS side, it automatically generates 2 connections, right, Jamie? That's always, isn't it?
That's correct. Yep.
And we chose not to. Quite honestly, we wanted to make sure we got it working. And as Carl said, we were not looking for best practice, but we chose to only set up one of the 2 routes. But I know both Azure and I'm correct me if I'm wrong, AWS both support active-active dual connections. So you absolutely could do that. And Carl's point is 100% correct. We didn't do that in this case because we are, quite frankly, not running a production environment, and we've got pretty tight control over it.
We do actually have redundant connections from AWS into DC2. We don't have redundant connections between AWS and Azure for us right now. So we're running the both, best of both worlds in this scenario.
There you go. There you go. Yeah. So, I mean, that's one thing I think is pretty cool is the 3 of us came together, and I'm going to talk about that kind of towards the end, why it's important that all 3 of us came together. By the way, I see we do have a question in the Q&A. We'll absolutely get to that. I like doing the questions at the end just from a timing perspective. So that's a great question. Simple answer to that question, by the way, without giving it away, is yes. But all right, so Carl, is that pretty much covered, or was there anything else in particular?
Yeah, just really wanted to push home the fact that what we've done here was just primarily an effort to design the network in a sense that we could actually have some nice conversational, valid discussion points on how to set up this kind of connectivity. So. Yeah, effectively, we just have a routed link between our data centers. I won't really say whether or not we're using static routing or a dynamic IGP. That really comes down to preference. It kind of pulls in some higher level scope. The organization, what kind of staffing, what kind of knowledge is on that staffing for deployment and subsequent management and troubleshooting. So. Yep, the networking and network security aspect of the on-prem side in relation to cloud, it's a lot of VPN, and then it's the on-prem hardening and defense side of the enterprise. But the design here is just effectively enabling administrators to have flexibility with like policy-based routing in order to do failover load balancing, that sort of thing. And the scope literally spans all the way from just a dual WAN on-premise kind of setup like we have here, all the way up to a lot of the SD-WAN heavy multi-site kind of deployments. So
yeah, absolutely. And I'm going to just take from there. And I'm really glad you brought up the SD-WAN. I kind of feel like we did this. We popped open the hood, and we're doing it certainly not necessarily at the absolute lowest level you can, but at a pretty low level. And I know on the Azure side, for example, now we have the Azure Virtual WAN, which is going to give you this one unified environment to manage all of this. And I'm not sure if AWS has that same kind of virtualized WAN management system, Jamie. Are you aware? Put you on the spot.
Now off the top, we're actually coming into a transit gateway. Yeah, we're running a hub and spoke model
Yeah.
from master account, which we then
Oh,
link.
and by the way, Jamie, I'm going to get to that. You're going to have to go through that whole thing. I was
Okay.
just saying that we do have that kind of software-defined WAN concept and in the cloud as well.
Yeah.
Is what we've got. Okay. So what I'm going to do now, so that's what we've got. One thing, notice we've got this RDP to Windows Server 2016. That's actually what I'm going to go into because I'm going to be an on-premises client. I'll show you how an on-premises client could work and how frankly transparent it is and frankly must be for an effective hybrid cloud solution. All right, now on the Azure side, and I don't have every detail here, but I do have quite a few of them. In the Azure side, we've got the following elements. First of all, I do have a hub and spoke. So I've got my hub network and I've got two what are called peered networks. And I've got peering relationships here between both of these and the hub network. Okay? And the hub network actually has three subnets. I've got the default subnet, which really actually isn't doing a whole lot. I've got the gateway subnet, which I need for my virtual gateway, my VPN gateway, right? And I also have a third one because I've got a jump box that I can pop into if I need to, right? Now, off the data subnet, I don't actually have, or the data, this is actually a data network, that shouldn't say subnet. Off the data network, I actually have what's called a private service connection to an Azure SQL server with an Azure SQL database. And what that does is it really actually gives the database a local IP address in that network. Now it's fully managed by Azure, by Microsoft, but it's sitting effectively in that data subnet. Now there's a few things that are a little bit strange with it. For one, you have to have a private DNS zone set up in Azure for that to work because, and this is just an oddity with the Azure SQL database, you have to connect to it using its public FQDN. But the cool thing is that what's going to happen is you're going to use DNS and it's going to route it to that private endpoint. I'm going to show you exactly where that does and does not work. All right, so we've got that, and really the purpose of the data network is again to tie in this service, right? So I'm just running my database as a service, and then in the web app, I've got a default subnet, and I'm running an Ubuntu server, and you can see the IP address there is 10.1.7.36, which was supposed to be 10.7.1. But I transposed that early on in the process, and we just decided to run with it. So I'm violating good network IP allocation rules there, but by the time we realized it, we're like, okay, we'll keep going, and it works just fine. Now, over on the far side, oh, and by the way, I'm sorry, that is also running that same workload. It's running a Docker container that's running my REST API host. And now I also have my VPN, VPN gateway, and I have one VPN gateway connection drawn. There's actually two. In Azure, you set up local gateways. Those are going to represent, in my case, again, I've got two of them. One represents the AWS connection, and the other represents the on-premises connection. And once I have that, then I set up the connection between them. And one thing to note, and you will see this when I go into the how we set this up demonstration, is that connection is really where you do all your hard work. That's where you're going to make sure that your policies set, right? Both your phase one and your phase two, even the protocol levels, if we're using pre-shared keys, so the pre-shared keys have to match. And really all of that hard work goes into setting up the connection itself, right? And so from a networking side, everything really over to the left of this line was just very straightforward, absolutely every day, what you do in Azure. And I have to say, other than a couple of issues that we ran into, which I'm going to talk about, even the side on the right, when we're connecting up to both on-prem and AWS, was relatively straightforward. All right, now the third spoke here, if you will, is AWS. And Jamie, are you okay if I turn this over to you?
Yeah, absolutely. So we set up, you can do this multiple different ways, depending upon the complexity or the maturity of your organization. For us, we run the exact same what Trace was talking about, a hub and spoke model. So all of our VPN connections come into our master hub account on a transit gateway, and then you can link that transit gateway into a spoke. The spoke for us is going to be the VPC just in a demo account. That could be a VPC in the same account. It could be separate account. We run multiple accounts for that. Inside that separate account, we have the same split on subnet for our network, where we have private subnets, we have data subnets, we have application subnets for that. So we have a BGP connection coming from our data center up into our master hub transit gateway, which then routes over into our demo account, which grants access via routing rules from our data center into this 10.7.0.14 EC2 instance. We also run the exact same connection, VPN between Azure and AWS into our master hub, and via routing rules inside the transit gateway, we can route over to our spoke in our demo account, which then grants access from Azure into the same EC2 instance, 10.7.0.14. So at a high level, that is the how we have this set up from the AWS side for that. The only difference we have on these two connections is we have a BGP connection between our data center and our master hub here with redundant tunnels. Between the Azure and the AWS, which we can talk about later if need be, we run a static connection because BGP is not feasible between these two cloud providers. So
At the moment, we have hope that they will continue. It wasn't that long ago that without using some kind of network appliance on one side or both, that you actually could not set a direct VPN gateway between them. And now really we can absolutely do that. But again, we did find that despite, I think it's fair to say, despite our absolute best efforts, the blogs were correct that you're right now not likely going to be able to set up BGP, which honestly, I know on my side really was very little effort anyways. I really just, when I set up my local gateway, my local network gateway, I just tell it what IP addresses are there and I'm good to go. And I'm assuming you had a similar, obviously different, but a similar experience on your side, because I know once we decided to stop attempting BGP, we actually had it up and running pretty quickly.
yeah, if you want to move away from some of the complexity we have here and some of the managed services, I'm sure we can get this set up and stuff. But just for the sake of this demonstration, kind of leveraging on the resources between AWS and Azure and what they offer without doing a whole lot of manual configuration, we had to move to like a static setup for us. So
yeah. All right. So there we go. That is really kind of how we set this up. Now, as far as issues that we ran into, and we will never talk about how long these three relatively straightforward issues took us to figure out, but in our defense, particularly that first one, that was a little bit unfair. So we're setting up, and honestly, we've got the connectivity between on-prem and Azure, and we've got the on-prem or the connectivity. We've had the connectivity between on-prem and AWS, and we're good, right? And so, we're setting it up, and both sides of the configuration are done via infrastructure as code. I'm using primarily a Azure resource manager template with some scripting in addition to that. And Jamie is using an Terraform plus what's our?
yeah, we leverage Terraform, and we wrap TerraGrunt around Terraform just due to the multiple accounts and services that we run with that. So.
Yeah. So I mean, honestly, if it had all been smooth, that would have been great. So we're running it, and we can't get this connectivity. and we had put in a pre-shared key. Quite honestly, I had generated a GUID, and we were using that, and that worked great between me and on-prem. And then we look over, and finally we realized that the process wasn't accepting that, and that on the AWS side, there were some invalid characters in that pre-shared key, so it was generating its own, right? And so, okay, fine, let's go ahead and take that pre-shared key, and I'll just use that on the Azure side. Don't care, right? So we're going, and it's not connecting. Everything looks like it's okay. Finally, I was wondering, I wonder if we had the same thing in reverse. Long story short, we did. There were characters in the pre-shared key that was generated by AWS that did not work in Azure. So long story short, when you're setting up this connection, a VPN connection between both Azure and AWS, pick a key that's going to work in both environments. Right? Now, the other thing that was pretty interesting was the IKE versioning. And both systems, Azure and AWS, support bov IKE v1 and IKE v2. And we were initially scripting it out and pushing it to IKE v2. But whether somewhere along the line, it was coming up with one of the sides was coming up IKE v1. And that took us a little while to figure that out. But once we did, that's really easily solved because it's an option for both sides, and we just set both sides up to use that. And then finally, the only other issue that we hit was the fact that you can't use BGP. And there were a number of kind of how-tos out there. You can find them out there. You know, they're like, here's how you do it, and you can't use BGP. But we're like, both sides support BGP, and let's just go and let's be smarter than everybody else. Long story short, it didn't work out, and it had to do really with the BGP. Was it neighbor IP address? I'm so bad with specific terminology unless it's Azure.
Yeah, we got about as close as you could get to it. When you get to the phase 2 connectivity on it, the IP routing for the internal hop on it, AWS has one predefined set, and Azure allows you to define another, but not the AWS set. So you kind of get like a chicken or egg there, and one of them's got to come first, and you can't do that. So.
And neither of them wanted to not be first. So and honestly, it was fine. I think if you're doing this in production and you are using the built-in, VPN connectivity between Azure and AWS, then obviously it's going to take a little more as far as the way that you're going to define your routing. And I will, like I said, I will tell you when I set up a local gateway on the Azure side, I really just have to specify I'm either using BGP or that I have to specify the IP address ranges that I'm going to use to connect up to, which was really pretty easy. You have route tables, obviously, that you can define in both places. You can use appliances, so there are a lot of solutions around that. But long story short, if you're using that native connectivity, just assume until further notice that you're not going to be able to use direct BGP. All right, now you get to see something. So that's what we set up. That's what we run into. All right, let's play a little bit here. So what I'm going to do is I'm going to take you through the Azure configuration and also the AWS configuration. And then the end of this is I'm going to show you that it, in fact, actually works and what works and kind of where things are. So let's go ahead and let's just jump right into that. And what I have, that was probably a little bit abrupt. If you are familiar with Azure, you are probably familiar with ARM templates, and that is what you have in front of you. This is Visual Studio Code. It is my favorite tool now in all the world, and it really doesn't matter that that's the case, but that's what you're seeing. And what this is, and I can zoom in just a little bit here. Okay, so I have these resources, like these are network security groups that I've set up that are running. I've got one in the web and one that's set up in where my jump server is. And let's get this out of the way a little bit and get a little bit more here. Okay, I also have virtual networks. I actually have 3 virtual networks set up. I've got a hub virtual network, a web virtual network, and a data. And you know, you can go in and I've got IP address ranges set up for these. I've got subnets set up for these, and network security groups. And obviously I can drill down, and I'm not going to take your time drilling down into these. We do have lots of courses that drill down into these. I've got network interface. I've got my virtual machine configuration. The virtual machine configuration has a custom script that installs Docker automatically on that. And then I've got my gateway. So I create a public IP address for my gateway, and then I set up the gateway itself. And really not that much to the gateway. It's just associating the gateway with a virtual network. It's associating with a public IP address, and it's setting it up saying, okay, the tier, which is gateway 1, tier, that's just SKU performance tier. It's route-based, and I want BGP to be available on it. I also automate the connectivity between my hub and my 2 spoke virtual networks. Now, the only thing that I'm not setting up here is the actual configuration and connection to both on-prem and AWS. Now, I did this via a script just because it was pretty easy to do, and it's actually really easy to see the components that are here, and it's actually completely reproducible. So, you know, I've got some variables up here. I've got the local gateway IP. That's important. That's going to be the actual public IP address of the other side. So I'm connecting to AWS. This is where I would put in the IP address from the gateway device in AWS. This would be the ASN of the gateway device. This would be the peer BGP. This would be the pre-shared key, and then forcing that protocol to IKEv1 so everything works. Right? In Azure, what you do to set all of your IP settings, we have this IPsec policy. Now, if you go and you take a look at some of the older documentation, it'll tell you that the VPN that you have in Azure is limited to a very small, really fixed set of settings, and you have to be able to match those. Really, a good couple of years ago, they added in this idea of a policy so that we have the ability to really be very precise in what we say. Now, one thing you're going to have to look at when you're setting this up is that not every VPN gateway is going to have the same available options. And so what we did here was I printed out the options that were available on the Azure side. And then I just gave those, just collaborated on them and said, okay, on the AWS side, how are you matching? And on the on-prem side. And I think, and I put this to both Jamie and Carl, I really almost think the only thing that really didn't almost fully align were the DH groups, right? I think there's a few DH groups that are not covered by Azure. Was there anything else you saw, Jamie, when you were looking through it, saying, hey, I've got this on the AWS side?
No, I think the rest of it was pretty straightforward. You can, like by default, all of them are selected, and then it reads left to right on that for the acceptance of it. But there's quite a bit in there. But we narrowed it down to just say, like, these are the ones we know we're doing. And so we just turned off all the other DH groups from being used.
Yeah, there you go. Yeah, and it was kind of interesting. That was one thing with me when we were connecting up is, again, it's all pretty much the same thing. But as an Azure person, I have to admit, I kind of liked the way that the options were handled on the AWS side. That it was very much okay, here's everything that's possible, and you can just you can just really kind of negotiate what protocols and options you're going to use. So I thought that was pretty cool. And Jamie knows it hurts me to say that I thought something was better in AWS than it is in Azure, but it was good. So anyways, on my side, I set up the policy. I get my virtual network gateway, and I create a new gateway that's going to point to my local network. So that's pointing over in the AWS side. Those are all pointing over to AWS. And then I set up my connection, and somewhere in here I've got the shared key and also the IPsec policy. And that's it. That's the configuration on the Azure side. So it was all scripted out and really very reproducible. All right, Jamie, because I am not a TerraGrunt person, I've got your scrub TerraGrunt files here. Which one do you want me to pull up first?
Probably the main
Main. All right, you want to just briefly go through what we have here, and I'll scroll as you tell me to?
Yeah, absolutely. So, so we're leveraging just a public VPN module, which you can find in the Terraform registry, which we can share out for you. But that source in the VPN module gateway is the one we're using for that. And there's only a few of the resources in it that we're setting up. This is not the full setup for us, again, since we're using hub and spoke and we have this between multiple accounts on it. This is just the VPN connection between AWS and Azure. And we use RAM in AWS, which is the Resource Access Manager, to share out our transit gateway between our master account and our sub accounts into that. And so that transit gateway is automatically shared into the demo account, which we can then just attach the VPC in that account to. So what this is doing here is we are just passing in the TerraGrunt wrapper around this module, passes in the variables, which are on the right-hand side of these parameters you see down here. So you see var.vpn, var.static, var.connected transit gateway. Those are variables that we pass in, much like a programming function, to this module. And that allows us for all the different accounts to change that. For example, like in a demo dev account, if you were spinning up EC2 instances and you only wanted one small instance, you could define that, then use the exact same script for staging or production for more instances, larger instances. We've had this set up for a while. Some more of these features are available inside Terraform now that weren't readily available, in prior times when we had this set up. So some of the stuff is redundant, but now we're invested into it, and it works out pretty well for us. If you switch over to the TerraGrunt file here, and probably just scroll down to the bottom here where you can see the inputs. These are just all the variables that we pass in. So we, much like a programming function, you define what the variable is and what the value for it needs to be. So you can see for our static private routes on this, we had picked the 10.1.7.0/24 subnet for the Azure side of the hybrid cloud on that. So those are the routes that we need to attach into our transit gateway to go over this VPN into Azure. You can see the customer gateway IP address. Right now I just have it set to home, but that would be the public IP address of the Azure side of the VPN. And then just a couple names for it here. There's a couple other additional parameters in here. So I have towards the top of the screen there, you can see connect to transit gateway true. We're attaching this VPN directly into our transit gateway in our master account. You don't have to use a transit gateway to set up the VPN between these two subnets. If you are not just getting into AWS, but you need to connect, Azure and AWS or AWS and on-prem for that, you can do just a direct VPN into your VPC in any account for the connectivity to it. This is just defined for us if we're going to actually use a transit gateway or a direct connect that's not linked into the transit gateway. And then there's also the other option you can see there really quick is the VPN connection is only routing static routes. That's because the BGP or the dynamic connection in AWS does not work between AWS and Azure. So
at this time.
At this time, correct.
All right, so there we go. We've got the Azure configuration and we've got the AWS configuration. And, what's pretty cool is, in both cases, we're looking at infrastructure as code definitions, really. And, this concept of with the TerraGrunt and using that to really control what I would consider to be parameters, you have exactly the same thing over on the Azure side with the ARM templates and the ability to inject parameters with that as well. And I use that all the time for spinning up various environments that I need to in the Azure side. So, and again, that's one of the things that's pretty cool here. There's certainly differences but then you also see so much parallelism to what you're going to have going on, if you're on-prem or anything else. So this is our environment, right? And again, just a real quick thing here. Just kind of remember what we've got. We've got 3, and I'm doing this with the mouse, so please forgive me. All of this is running. We've got our Azure, we've got AWS. This is AWS. I'm gonna put a W here so you don't have to watch me write multiple characters. This is O for on-prem, and this is A for Azure. Okay, and we're connected up. We've got VPN connectivity all the way through, and we've got workload running in each space. It's a REST API. And we've got a database up here. I'm so glad that this drawing is getting recorded. Okay, now the other thing that I have, and that I'm going to pull up in just a moment, is I'm going to pull up my demo client, and that's going to be my Windows 2016 server, but it's just a client. And what I'm going to do with that is I'm actually going to have that connect directly to my server that's running in Azure, and then the Azure server is going to reach out and really hit everything else. So that's really what we're looking at. And let's actually look at how that works out. All right, so here I am. I am currently connected, and we can see this if we pop up here. Okay, you can see I'm connected over here to 10.1.7.36. That's the web server that's running in Azure. And it has this incredibly well designed web page here. You can see a lot of time was put into the user experience for this web application. And what I can do though is I can put in some test URLs. So for example, maybe I want to check out connecting just to this one. So that's going to be 36. Right, but I can also connect up 7.0.14, and I can connect up to 192.168.1.100. Okay, so what'll happen is this is going to go and it's going to reach out to all of these, and essentially it's going to go and send a test ping to them and make sure that it's going to get back the data that it's expecting. So
again, Tracy, for clarity real quick here, where are these IPs located at? Which one's going to?
Okay, absolutely, great question. Let's zoom in here. Let's see there. Okay, so the 100 is on-prem, the 14 is in AWS, and the 36 is in Azure. So we're connecting up to one of each. And I'm going to go ahead and just test connection, and it's retrieving the data, and back comes the data. So that means it works, and you just need to trust me, and we're done. No, I'm going to go ahead and take a look at what we have, because there's a few things I think are a little bit interesting. And again, just keep in mind, it kind of said, all right, let's just pull some data back just to make sure everything's connected up. So let's take a look. All right, and here, that first one, all right, I've got a host DNS, and that's literally just the name that I told Docker to give the VM that, or the container that it started up. Now, the connection to that, the client IP on that, the call, came over 172.17.0.1. That's an internal IP address from Docker, right? Because I actually connected up to the IP address of the host, right? But Docker's got port 80 mapped. And so it's going to bring it in, but as far as my client is concerned, that's where it came from. All right. Now, notice this SQL Server equals true. And what that means is that my application, my REST API, was able to reach out and make a connection to SQL Server and actually drop a little bit of data into SQL Server. Okay. Over here, this was in AWS. And again, literally, it's the same image running in Docker on different machines. Now, what's pretty interesting here is that this is coming from 10.1.7.36. So it's actually getting the right IP address of the server that sent the request. Notice here, running, and this is, to me, the coolest part of the whole demo, running from AWS. A server running in AWS was able to connect up to a service, a platform service running in Azure. And I only had to do one thing to make this work. The only thing that I had to do, because there's this requirement on the Azure side that the request has to go to the actual FQDN, the public FQDN, all I had to do was really inject a host record into that container when I started the container that mapped that public FQDN to the private IP address that is actually associated with the server. And that's important because I've got that actual public endpoint. The public endpoint is there, but it's absolutely locked down. And I'm going to show you that as kind of the last part of this because I think it's worth taking a look at. Now, in addition to those, of course, I also have my on-prem. So here's my on-prem. And notice, same thing, as far as on-prem is concerned, that request is coming from 10.1.7.36. So that's coming from the web server that's sitting in Azure. Okay? And such as on-prem. Notice, however, this did not connect up to SQL Server. Okay? And the reason it did not connect up to SQL Server is because I did not inject that host file setting into this container. Right? So this container is still trying to go out to the actual public endpoint, but that public endpoint is, for all intents and purposes, closed. Okay? Another thing to notice, and you kind of see this for all of these, this is the local IP address of the server. They're all the exact same IP address. That's because they're running in Docker. So these are just Docker containers, and that's the internal IP address that was given to the only Docker container that's running on all three machines. Right? And so that is, hopefully that is slightly anticlimactic because really all the hard work was getting all this to work. I do want to show you a couple of other things. First of all, because, I know we have a lot of networking people here, and I'm sure you would want to see lots of pinging. I'm sitting on my jump box, which is in the Azure side, and from my jump box, I can ping 92.168.1.100. I'm really glad the overall demo worked. Oh, good, that worked too. Of course, that was going to work. All right, and so there we go. I'm pinging. I'm getting connection. Pretty good connectivity there. And if I want to go ahead and ping 10.7.0.14. I'm getting across to there. And finally, this would be trivial. 1.7.34, 36. There we go. And that's connecting up, of course, to the local. Now, the cool thing with this is I've got all kinds of transitive routing going on because my for example, the machine that I'm sitting on here is actually in a different virtual network, and thus, of course, a different subnet than the web server I just pinged, even though they are, all in Azure. I didn't have to. I have zero added route tables in the Azure side at all. The only thing in terms of routing that I've got on the Azure side is because we couldn't use BGP. I had to go ahead and set up routing for, or just really the IP address range that was over on the Azure side. Jamie, how much routing did you have to set up?
It's pretty minimal. On the hub transit gateway, I basically set the routing over to the 10.1.7.0/24 network to point to the transit gateway, which the VPN is attached to, so it knows to route over to that. And then the same thing in the spoke on the demo account is we point that same CIDR block to the transit gateway, and it knows to route up to the hub and then out over the VPN. So it's pretty small.
There you go. And Carl, other than anything you had to do internally to get between the data centers, was there any particular routing or other configuration that that you felt was, wow, I'm surprised I had to do that?
No, just between the two data centers on-prem, simple enough for me to allocate just a small unused subnet and do a layer 3 connection between them. And I kind of alluded to it before because it's it's a little bit underwhelming, but for the purposes of the demo, I'm just using static routes. So
Yeah,
there's of course more elegant and more automated / responsive solutions with internal IGPs, that sort of thing. But yeah, to keep it simple, yeah, just a static route.
All right, there we go. So, you know, I found, like I said, as is often the case, that we had, you know, some little gotchas that took more time than, you know, in reflection, they necessarily warranted. But that's the nature of troubleshooting. And you know, it was interesting to me because I think in a very real sense, the process that we went through, even though this is, you know, a demonstration, even though this is, you know, we set up sort of a minimal proof of concept, right? The process we went through, I think, is a really valid architectural process that you would go through in a hybrid cloud. You know, we have our on-premises subject matter expert that is really completely immersed in not only the technologies, but our configurations on-prem. And we actually sort of had two of those, both Carl and Jamie. Jamie is our, you know, our absolute go-to for AWS, and I'm our Azure guy, you know, and we had to work together and we had to collaborate to really enact our architecture. And but that was really the process. It's kind of fun. It was, I have to tell you, once we saw that ping traffic going through and I could SSH everywhere, that was a very, very good feeling. All right, and so that's pretty much what we have. Now, I do have some questions, and I'm going to go through a number of questions were answered. I believe Carl probably answered those. I'm going to actually go ahead and call those out, read those out, give the answer as well, because I believe you're not going to see the answer to a question unless you were the person who actually answered or asked it. So I'm going to go through the Q&As that have been answered, and then I'm going to go through the open Q&As as well. So there's a question: who's going to provide the IPs for the VPN connection? That was actually answered with a question. So that one will be taken, again, that was from Danilo Torle, and I'm sure I got your name wrong. Okay, and I saw that pop back up as a confirmation. Then there's the, are you able to use CSR 1000V routers to overcome some of the three topologies identified? Carl says, for this demo, we use open source router, BYOS, as the on-prem side, but yes, also leverage a CSRV and an ASAV when testing. That is all absolutely true. I will also say that both Azure and AWS support a wide range of virtual network appliances. Well, Jamie, that is a safe thing for me to say, right? That they are in fact supported in AWS as well.
Yeah, we don't use any of them for our
Right.
workload, so I don't have any experience with them, to be honest with you, but yeah.
Yeah, and you know, and I'm talking about, now I will say that on the Azure side, the Azure ASA apparently is not very good, but you know, whether it's Palo Alto, F5, ton of other solutions, there are predefined appliances that you can just spin up in the cloud, right? Not to mention the fact, of course, that you have such a wide range on-prem. So, you know, the simple answer to that is yes. There we go. Okay, I mean the IP to establish VPN connection. I think this was a follow-up here. I mean the IP to establish VPN connections on-prem and cloud. So the on-prem public IPs were delivered by the ISP that services the on-prem. On the cloud side, the provisioning process will deliver the public IPs to you automatically. That is absolutely correct. Now, there are some things you can do now on the Azure side. For example, you can actually reserve a block of public IPv4 addresses on the Azure side, and when you set up a public IP address object resource, you can connect it up to that, so you can have control over it. Of course, that's going to all cost money. What we did in this case was, I just went ahead and said, okay, go ahead, create the public IP address with a dynamic endpoint. When you do that, it's going to get assigned. When the public IP address is assigned to something, in my case, that public IP address was assigned to the virtual network gateway. All right. And I answered that one. All right, now here's an interesting one. Do you consider an overlay network or an SD-WAN network concept for hybrid cloud? And Carl answered, great answer to this one. Absolutely. In addition, effective planning of resource and workload location is huge. Absolutely true. So there are options for traffic engineering, SD-WAN, policy-based routing with IPLSA, as well as, quote, homegrown internal development initiatives. In our case, we were assuming ISP1 to have a /29 and ISP2 as a /30, what you might typically find in the SMB market. Great answer. Another question, will the video be shared? And the answer is absolutely. And I'm going to have, in just a few minutes, Brittany come back online, and she can answer any of those kinds of questions, because she is absolutely the keeper of that. So those were the ones that had been answered by Carl. And now I'm going to go through and answer the other questions. I think I have 8 questions here that are not answered yet. The first one, is this a full mesh topology? It says mesh, I assume that's mesh. I mean, in case the link between DC2 and AWS is down, I can still reach AWS via Azure Cloud. The answer is yes, with an asterisk. It certainly is. What we did not do is we did not implement routing tables for any kind of slingshot. We certainly could have done that, but in this case, we're like, we've got the direct connection. We have, the almost exclusively BGP-based route announcements. So we're not going to need that. We actually talked about that, and we talked about what would need to be done on each side. And I would say it was not anything that was excessive. All right, so there you go. The simple answer to that is yes. All right, next question related to Azure and hybrid environment. Do you recommend convert our AD users on-prem to Azure AD Premium? Well, Microsoft certainly does. They would love you to do that. Here's the thing. Azure AD and Active Directory are 2 different services, right? And whether or not you need Azure AD comes down to whether or not you're going to have web-based authentication, is really what it comes down to, right? Because Azure AD is about supporting authentication through OAuth 2, through OpenID Connect for web-based solutions. So for example, if you were running certain services, if you were running an Azure SQL database and you wanted to have actual Azure AD logins, or as opposed to SQL Server logins, and you would absolutely need to do that. If you're integrating with Office 365, excuse me, Microsoft 365, because they renamed it. But if you're connecting to Microsoft 365, you have to have Azure AD. You may not even be aware that you've got Azure AD, but you do. And if you're connecting up to any of literally thousands of other applications that work with Azure AD, then yes. Now, it's not so much converting as it is to synchronizing, right? So if you already have your on-prem Active Directory, you're still going to have your on-prem Active Directory. What you're going to do is set up a synchronization topology where you're synchronizing those accounts into Azure, all sorts of details way beyond what I want to talk about. But then that makes those same accounts really applicable for your web-based authentication. Now, whether or not you need to use them as Azure AD Premium, depends on a number of things. And what it really comes down to, well, two categories. One, how many objects do you have? Because there's an object limit in the free tier of Azure AD. And two, do you need to use the features that you have in Azure AD Premium or Azure AD Premium 2? And that is the discussion point for Azure AD. So it's not so much whether or not it's a hybrid environment as far as going premium. If you have a true hybrid environment, you are probably going to want to have Azure AD. All right, so that's a really long-winded answer. Sorry about that. Is it possible to share the scripts? I will talk with Brittany. I can certainly share the sanitized versions of the scripts that I've got for Azure, for the ARM, and for the PowerShell. I will talk with Jamie offline to see if A, it's applicable, and B, it's practical to share the Terraform and TerraGrunt.
I can answer there now. Yeah, we should be able to share that, so it's not a big deal. There's no secret stuff in there.
All right, I was going to not put you on the spot in case the answer was no. So thanks for coming in on that. So yeah, it's definitely, we can get that, and that just means more work for Brittany. So we'll be nice to her. Does a provider support certificate-based IPsec tunnels? I should know that for Azure off the top of my head. It certainly does on the point to site, so the individual. I know from what I was just looking at when I was connecting up, Jamie, correct me if I'm wrong, you've got site-to-site certificate-based with AWS, correct?
Yeah, AWS announced about a year ago site-to-site VPNs that support certificate authentication. And if you just Google for certificate-based VPN AWS, you should come up with a article that was written in March of this year of how to do that. So. And
here's the thing. I have my 80%, or the answer I'm 80% sure of with Microsoft, with the Azure side, but I'm not going to give it because usually the answers that I'm 80% sure of, I get wrong 80% of the time. So I will go ahead, and that is one that will get answered. It's a great thing, Alex, that it's in the Q&A. All right, I've got another one here. We got several more. By the way, if you need to take off, all of this is getting recorded. I do like to try and get the answers, the questions answered as we can as we go through. All right, so next, assuming, for example, you have the web tier workload available in Azure, AWS, and on-prem. Oh, this is a great question. Are you using a load balancer to distribute the load? The answer is, I'm not in this case, but you absolutely could use it in, and you would want to use it in a practical sense. And there's a couple of different ways that you can do that, depending on whether you've got public or private endpoints that you're connecting to. And you would assume that they're probably private endpoints. And without going too far down the path, one great solution for that, if it's REST-based, if it's all HTTP, HTTPS, on the Azure side, we have something called an application gateway, which sounds kind of like the virtual network gateway, but it's a completely different thing. It serves actually as a load balancer that can do both public endpoint and private endpoint load balancing across a wide range, but also has built-in firewall capability, which is pretty cool. So, and the cool thing is I could use that, for example, and I almost put one in to this demo to provide a public endpoint, but I decided that really wasn't what I wanted to go for the demo. But absolutely on the Azure side, and I know I'm not even going to make Jamie say anything. He can nod his head if he wants, or he can jump in, but you're gonna have the same capabilities on AWS, and obviously with on-prem, as long as you've got that connectivity, it's transparent. It can be, particularly depending on what layer, right? The cool thing about the application gateway is that it actually operates on layer 7, so it's well above any of this, any of the connectivity we're doing at the IP level. All right. Sorry, I got a little bit later. May I see the topology that you are working on? I can bring that up really quickly if I can find it. Oh, it's literally right there. I will show you the big picture topology. There we go. At the highest level, that is what we're working with. We've got Azure, AWS on-prem. We've got a virtual machine running in each one of those services. And we've got a platform as a service database service running in Azure. And we've got full connectivity between them. All right. So your hubs are on-prem and your spokes are Azure and AWS and between the clouds. You guys are using the transit gateway with static routing. Are you running a VPN between Azure and AWS via static routing over the cloud, SPs, public IPs? That was a lot of question. And the answer is yes. This is a simple answer. So actually yes and no. So we are running more of a kind of, would we consider this a mesh topology that we're looking at between the sites? It's not really a hub and spoke because they're all connected. So
yeah, so Azure and AWS have fully specified VPN policy pointing to each other's public IP. Right. So that's the definite yes part. And then yeah, it's a mesh. So just to boil it down, the Azure to AWS and AWS to Azure is all fully specified, whereas AWS to on-prem and Azure to on-prem would be a route-based VPN running BGP.
Yeah, that's the thing. And thank you very much, Carl. You know, the reason why we're partially static, is really what it comes down to, is because frankly, we really wanted to run BGP between Azure and AWS. It just wasn't going to happen. And, you know, we needed sleep and needed to see all of our significant others, et cetera. So we decided to stop going down that path. But you have that. Now, I will say that within both Azure and AWS, internally, both of those absolutely are hub and spoke topologies, right? So you've got your meta topology, which is a connection between Azure and AWS and on-premises, and then you go down into your really detailed topologies in Azure, absolutely hub and spoke, same thing in AWS. All right, so I've got a follow-up to that. I got it now, Carl. Looking at the ping, the TTL is 62 between Azure and AWS. So you're using your on-prem as a transit. Actually, no, we're not using the on-prem as a transit between the two. What you're quite possibly seeing is some of the internals both on the Azure side and the AWS side for that. All right.
Yeah, from the on-prem side, it's 2 hops just because we're leveraging static routing between the internet egress when looking at on-prem to AWS versus no extra hops between the on-prem and Azure. So the trace routes will be different between the two. When you talk about sourcing from on-prem, the trace routes will be different. But again, it's just how you actually design the topology, the logical topology, whether or not that matters. It allows you certain policy enforcement points, whether it be security, NAT, HTTP proxy, that sort of thing. So there's a lot of reasons and considerations that go into it, but just for the purposes of the demo, it's a layer 3 routed link on the way to AWS from on-prem, which is why you would see a second hop versus no second hop to Azure, where it's a direct VPN peering between the two. So
there you go. And again, the Azure and AWS is in fact direct. All right, that clears all of the questions that I see. If you have any more questions, please feel free to ask them. Otherwise, one thing I'm going to do is I'm going to ask you, if you get a chance, follow me on Twitter. I have a pathetically low number of followers on Twitter, and always working to up that. I do, on the Azure side, put out announcements relative to what we're doing in terms of our content at INE for Azure and more broadly for the cloud. I will tell you, coming down the road, right now I'm working on an Azure development learning path. When that's done, I'm going to put out a course or 2 on hybrid IP addressing, because that is something that, as we've talked to cloud architects, just the idea of hybrid IP, just getting the addressing right is important. So in other words, please don't take the fact that I transposed a 7 and 1 in this particular webinar as indicative of the right way that we'll be talking about to do your IP addressing. It all comes back to DNS anyways. So in any case, again, thank you very much. And I'm done. I'm not seeing any additional questions. So if I have not put the intrepid Brittany to sleep, if you're around and you want to close this out, I think we're about ready.
Awesome. Thank you guys so much for attending. Once again, this webinar was being recorded. If you're watching via Zoom, you will get an email later on this afternoon with a link to the full webinar, as well as any extra resources that Tracy or Jamie or Carl sends along on my side. So we'll make sure you get all of that. If you are watching on Facebook Live or any other platform, we'll make sure that we link those extra assets later on as well, as soon as we get a hold of them. So that might just be a little bit later on those sides. But if you are already registered with us, you'll get everything in a nice big chunk. And if there were any questions for some reason that we missed, we'll take a last look at them and make sure we caught everything. But if not, we will reach out if we are able to answer those questions as well. So thank you guys so much. Also, if you go to INE.com, right at the bottom of the page, there is a webinar button. You can go there and see our upcoming webinars. That's going to be where we keep all of Tracy's webinars. It's a recording spot as well as upcoming webinars we have with eLearn Security and Ethical Hacker Network if you're interested in cybersecurity. So go ahead and take a look. That's at INE.com. Just go down to the bottom of the page under resources and check out webinars. So thank you guys so much for attending and have a great day.